Hello children, welcome to channel Sube. Children, today I am going to discuss question number 44 from the MCQ part of 2021 Physics New Syllabus paper. A straight conducting wire PQ, this one PQ, of length L and mass M has to be placed at rest on a frictionless insulating inclined plane. This one is a 3D diagram. So if we watch it from this side, the side view is like this. This one is the horizontal line. So inclined the plate to horizontal plane with the angle theta. So this the cross section of this wire, then we can see like this, the wire is like this. So this one is a 3D figure. Horizontal. A uniform magnetic field of flux density B acts vertically upwards. The flux density, the magnetic flux density is upwards like this, upwards as shown in the figure. The magnitude and the direction of the current I that should pass through the current can go this way, or current can pass this way. So what is the direction? That is what they want us to find out. That should pass through the wire in order to keep the wire at rest is given by at rest. Wire should be at rest. So let us use this diagram to describe this. So this wire, this one has mg downwards. So if we draw a normal to the surface like this, you know that is mechanics, not magnetic field. So this one is theta, grade 12. You must have learned these things. So this way the component of mg is mg sin theta. You must know this. This is grade 12 physics. So we are now talking grade 13. So mg sin theta. So we don't want these things now. You must remember that the component of force gravity is the component of mg is along the plane, along the surface is mg sin theta. So what they want is to keep this without moving down. So normally, you know, due to this gravitational force, the component of this gravitational force, what happens, this wire can't stay here stationary at rest, it slides down like this, moves down like this. So to stop that, not to move down, we are going to use this magnetic field. So there will be a magnetic force due to the magnetic field is this way. Magnetic field is this way. If there is a magnetic field like this upwards, and if there is a current towards or out of this wire, towards or into the wire or out of this wire, the current may be into the wire, then what happens, there will be a force perpendicular to this B, that is called magnetic force, this way or this way, always it is perpendicular. But we don't know whether it is to left or right, the force. Force is equal to BIL, you know, the equation BIL. When there is a current I and when there is a magnetic flux B. So, to find out the direction, we use left hand rule like this. So, we have to place our left hand to find out the direction of the force. If the current is into the wire, if the current is into the wire, like this, center finger current, center finger is pointed towards the wire screen, to the paper. So B is directed to the index finger is directed to the direction they have given B. So this way. So force must be then, if the current is into the wire, so I have drawn a cross. So I have taken, now at this moment the current is going into the paper. Yes, that is why I have drawn a cross here. So therefore I have to turn my center finger towards the paper like this, or to the wire. So then the thumb indicates to which direction the force is developed. So to thumb shows to right side. So the force is now to right side. So this one is we have to delete this one according to the current I got. According to current I considered, the current is into the paper, then force is towards right. But if the force developed towards right, we don't get any component upward like this, because the component of this BIL force is also to this way. So it is helping this mg sin theta and moving down instead of staying. So therefore this direction that I choose as the direction of the current is not working. So therefore I have to turn the current to opposite. That means I have to draw a dot here. The current should be coming towards us. That means here the point is P, this one. So the current should come out like this. So let us now place our left hand to check whether we get the force to the correct direction. So now B is this way, or vertically upwards. So the current now I have taken as out of the paper. Current is flowing out of the paper. So if the current is passing out of the paper, I have to place my center finger out of the paper like this. The center finger is little bit bent, so forget that. You imagine that center finger is erected towards our face, out of the paper like this. So the force, thumb indicates the force, the direction of the force. So it is to left side like this. Now the force is to left side if the current is towards us. So therefore if the current is like this towards us, that means if the current is from Q to P like this, current is from Q to P, then we get the direction of magnetic force towards this way, BIL. That is the force, magnetic force. So then we get a component towards upwards along the plane like this. Then since there is already a force downwards along the surface that is given by the gravity mg sin theta, so if these forces are equal each other, so there is no net force, therefore this can be stay without moving. We can keep this stay without moving. So now we know the current must be from Q to P, from Q to P, that means this way, from Q to P. So therefore let us first select the answers from Q to P. This one correct, Q to P direction, this one wrong, Q to P, this one correct, P to Q wrong, Q to P, this one again correct. So we have eliminated 2 and we have 3 correct answers. So from those answers we have to now check the magnitude. So let us now take the component of this BIL. So since this one is theta, this angle also is theta, then the component to along this surface upwards, what is the component? BIL cos theta. BIL cos theta. So upwards there is a force equal to BIL cos theta. It must be equal to the force, the only force downwards, mg sin theta. If that happened, what is the, what we can see, there is no resultant force, therefore this can be stay. We can make it stay. We can make it stay without moving downwards. That is what they want. The uniform magnetic field is vertically upwards to show the magnitude of the direction of the current should be passed through the wire in order to keep the wire at rest is given by wire at rest. The wire should not move. The wire should not move. Then that happens only if these two forces are equal in magnitude because they are opposite in direction. So that is the principle now we are going to use. So now what we have to do is to simplify this equation and find out the value of I. So let us take this cos theta to right side, then mg sin theta divided by cos theta, then B is here, L is here, I is isolated. So I equals mg sin theta divided by BL cos theta. So what is sin theta divided by cos theta? You know, that is tan theta. Tan theta equals to sin theta divided by cos theta. You must know that. Then mg tan theta divided by BL. That is the current. That is equal to the current. So direction already we have chosen. So what we got? Mg tan theta divided by tan theta. Tan theta is this one. Mg tan theta divided by LBO BL. So this one is the answer. This one previously we have chosen as correct. So now the magnitude tan theta divided by LB. So finally third one is the answer for this question. So let us check the answer sheet 44, question number 44. The answer is third one. We have chosen the third one. Yes, correct. We obtained third one as the answer. So children, I think you can understand it. Let us do some more target questions. Then you will be better understood. Children, I have designed a target question for you. The question number is 1, target question 1. So what you have to do is read the question carefully and try to solve it on your own without watching my video. After pausing the video, you have to calculate and find the direction of I. A straight conducting wire PQ of length L and mass M has to be accelerated by 2g downwards on a frictionless insulating inclined plane, which makes an angle 45 degrees to the horizontal. A uniform magnetic field of flux density capital B acts vertically upwards as shown in the figure. The magnitude and the direction of the current I that should pass through the wire in order to keep the wire at a 2g acceleration downwards is given by. There are 5 answers. So honestly, try this on your own. Pause the video now. I think now you have done. So now I am going to solve the problem. So children, let us first of all draw a side view. So like this, the plate is inclined, frictionless plane is inclined like this. The angle is 45 degrees. The cross section of the wire we can see like this. When we watch from this side, like this. So what we need, there should be an acceleration downwards equal to 2 times g. So we don't need forces upwards like this. We don't need, because we should move the wire downwards. So therefore we need forces to downwards. So already there is a force on the wire towards downwards in magnitude how much? mg sin theta, that is sin 45, mg sin 45. So this force is not enough to move this wire at an acceleration equals to 2g, because the maximum acceleration is g when it freely falling down. So this one is less than g. This one is able to make an acceleration less than g. So therefore we need another force. So that force we are going to take from the magnetic force, that is BIL. From BIL we are going to take that force. So to fulfill that condition, we need force to this way. The BIL force must be to this way. Then the component along this surface, along this plane, we can get the cos theta value, and we may be able to give sufficient force to get a 2g acceleration to this wire. So therefore we need not to this way, because if we received the magnetic force to this left side, the component will be upwards. So that is what we don't want. That is something that we don't want, because we don't want any force upwards. Only we want a force to downwards, so horizontally right towards right side. So let us now use our left hand to get this force. So suppose we place our left hand like this. So this, the direction of B is upwards, like this. B is upwards still. So if we placed our index finger like this towards B, and if we assume that the current is coming out, this one is the center finger, current is coming out from the wire, then the force generated is towards left side. This thumb is towards left side. So that is not what we want. So let us change the direction of current. So now let us suppose the current is going into the wire or into the paper like this. So we have to rotate our left hand so that our center finger is directed towards the paper like this. So B is still upward. So now you can see the thumb is towards right side. That is what we want. The force is towards right side. So like this we have marked it in black color, BIL. So this way it will work. That means the center finger is directed towards the paper. That means the current must flow into the paper. We see a cross here now. We see a cross here. The point P is here. In this diagram, point P is here. So that means the current must flow from P to Q, this way, P to Q. Input from P and furthermore goes towards Q, P to Q. So the current we know now, direction, we don't have to write all these things, direction P to Q. So let us choose this one, P to Q, then P to Q, this one also P to Q, Q to P, that is wrong, Q to P, that is wrong, P to Q, this one also correct, P to Q. Now we have decided the current must flow from P to Q. We decided it using this our left hand rule. So now we have to calculate to find out the magnitude. So let us do it now. Keep these hands aside. So what is the component? So let us write. Already there is a component downwards, mg sine 45, and plus there is a component coming from this magnetic force, that is BIL cos, this angle is 45, this angle, if this angle is 45, this one also 45, then cos, we have to turn it to this way, so like this. If it is this way, so we have to turn it towards the angle, towards the angle 45, because this one is 45. So cos 45, cos 45. So that is the force, resultant force. So we are going to use F equals ma. So instead of F we have to write all this total thing, because that is the component, that is the resultant force. So equals m. A is 2 times g. A is 2 times g. That is what they want. And an acceleration equal to 2 times g. So we write here therefore that. So mg sine 45 means mg 1 upon root 2 plus BIL. Again cos 45 is also 1 upon root 2 equals 2 times mg. So we can multiply by root 2 to simplify this, by root 2. So this root 2 cancel and remain this term. So mg alone plus BIL alone equals 2 times root 2 times mg. Then what we want is this I. So therefore we isolate it. BIL equals 2 times root 2 mg. This one goes to right side, then minus mg, then mg is common, then we can take that out of the brackets, then 2 times root 2 minus here 1, then divide by BLOLB. Let us check the answers. BL, they have written BL. So let us write BL equals I. So this one is the answer. the magnitude. So let us check. So what we can choose? -1, this one, first one. Already we have choose this one as the direction was correct. So now the magnitude is also correct. 2 times root 2 minus 1 divided by BL, so mg there is. So this one is the answer. Finally, the first one is the answer for this question. So children, I think you have done successfully. What happened to your answer? Is it correct or wrong? Correct. Then you are good. If you have solved it correctly, you are a genius one. You are a genius one. If you are wrong, don't worry. Just follow this video. Just let us do these target questions 1, 2, 3, 4, 5, 6. We are going to do 6 questions. Then you will be okay. Then you will be okay. Everybody has to do exercises. Then only you will be able to answer correctly. So let us now go to the target question 2. Children, I have made another target question. So question number 2. So let us try to solve this problem. Honestly, you have to do it alone by yourself without watching my answers. So pause the video, read the question properly, and choose the correct answer. A straight conducting wire PQ of length L and mass m has to be accelerated by g upwards on a frictionless insulating inclined plane, which makes an angle 45 degrees to the horizontal. A uniform magnetic field of flux density B acts vertically upwards as shown in the figure. So the magnitude and the direction of the current I that should pass through the wire in order to keep the wire at a g acceleration upwards is given by. So there are answers you have to do now. So now I am going to try this. So G upwards. So already mg sin theta is there downwards along the plane. So what we want is to move this with an acceleration equals to g upwards. So we should move this g, acceleration should be equal to g. So therefore we need a resultant force upwards. To get a resultant force upward, the magnetic force must be to this way. Then only we can turn it like this upwards along the plane. If the magnetic force is towards this way, we have to get the component to downwards like this, then we can't move it upwards. Therefore we don't want a force like this. we want a force like this. Therefore, we have to use our left hand to decide the direction of the current to get a force towards left. So let us try this way. If we want the force towards left, like this. So thumb is directed to left, so the direction is a little bit wrong because I have rotated the hand more than necessary, because I turned my hand so that it is matching with this one, this 3D figure, but now we are using this 2D figure, so it is not therefore suitable, but we can use it. So you have to imagine that thumb is directed to left hand. So this center finger is a little bit bent, so forget that. Imagine that center finger is directly straight. It is straight towards your face, out of the paper. So B is still upwards, so this index finger is directing upwards. So center finger is out of the paper, so then we get the force towards left side as shown in black color arrow. So therefore now we know the direction of the current out of the paper, so we can draw a dot here out of the paper. So P point is, the point P is here, so out of point P the current should come like this. Then Q to P is correct, P to P is wrong, Q to P is correct, Q to P is correct. For the moment we know these 4 answers are correct. Now let us try to find out the magnitude. Let us keep these hands away. So now this force has the value BIL. So the angle, this one also 45 degrees, if this one is 45 degrees. So let us get the component of this one along this way, along upwards, along the plane upwards. So what is it? So let us take this diagram down a little bit like this, then we have more room. So component is equal to BIL cos 45. Now we know these two forces are there, so we have to now use F equals ma equation. So F is the resultant force of these two, so this one should be greater than this one, then only we can move it upwards. Therefore we have to take this one as positive, BIL cos 45. That amount is greater, so minus this one is less than this one, so mg sin 45 equals m. A is equal to g. In the question, A is equal to g acceleration, so mg. So let us substitute the cos values. Cos 45 is 1 over root 2 minus mg. Sin 45 also is same, 1 over root 2 equals mg. So we can multiply by root 2 each term, root 2, then cancel, then we get BIL only minus only mg only, root 2 cancel, then root 2 mg. So root 2 mg plus root 2 mg plus mg, we take this man right, then the sign becomes positive, then I equals divided by BL. So mg common, take out of the bracket, root 2 plus 1, root 2 plus 1 divided by BL, root 2 plus 1, root 2 plus 1, root 2 plus 1, this one, root 2 plus 1. The direction also correct, we have marked it as correct, the direction was correct, previously we checked it. Root 2 plus 1 is this one, so fifth one is the answer for this question. So children, I think you can now understand little by little if you had problems previously. So let us keep doing this, then you will be okay. If you are wrong this time, then don't worry, we are doing more target questions, so at the end you will be okay. So let us now go to the target question 2. Those who successfully solve this problem can be happy. So you are genius, you are good. The others are also good because they tried at least, and little mistakes might have happened somewhere. When we simplify this, something might happen. This thing you might forget, or something like that happen and you get a wrong answer. So to eliminate those weaknesses, you have to do more exercises, then you will be okay. So children, here is our target question number 3. Let us do it as previously without touching my answer. Honestly, after pausing the video, a straight conducting wire PQ of length L and mass M has to be accelerated by G downwards on a frictionless insulating inclined plane, which makes an angle 45 degrees to the horizontal. A uniform magnetic field of flux density capital B acts vertically upwards as shown in the figure. The magnitude and the direction of the current I that should pass through the wire in order to keep the wire at a G acceleration downwards is given by, there are 5 answers. So try this. So now I am going to start. The angle is given 45 degrees. So the wire is like this. So already there is a force downwards, mg sin theta, mg sin 45. The angle is 45. Then what we want is to get a motion downwards with acceleration g downwards. So A should be g downwards like this. So then we don't want any force upwards, because that will not help what we want. We need extra forces downwards. So that means we need a force this way, because we are going to take it from magnetic force. Magnetic force is always perpendicular to the flux density. Therefore we can't get a force this way directly, but we can get a force towards right. So towards right, to get a force, to which direction the current should pass along this wire. That's what now we have to find out using our left hand. So you have to place your left hand like this. First of all, you have to rotate your left hand so that the force, first of all you have to direct your index finger towards upwards like this, because that indicates B. Then your thumb to left you have to turn, because the direction of force that we need is to right, not left, right, like this. You have to turn your thumb towards right without changing this index finger. So then automatically your center finger is directed towards the paper, automatically that happens. If you kept, first of all you have to keep all these three fingers at right angle each to each other, right angle. So then without moving your fingers, you have to rotate only the hand. Then you get this like this, your hand. Then you get your hand like this. Thumb should be directed towards right, like this, because that is the way we need the force. So thumb denotes the force, the direction of force. So index finger denotes the direction of flux density B. So center finger gives us the direction of current. So now we know the current should be into the paper, because the center finger is directed automatically into the paper. So now we can mark the current, the direction of current should be into the paper. So there should be a cross here, cross. So the point P is here. That means the current should enter from P like this and go further to Q. Then P to Q, the current should be P to Q. This one correct, this one correct, this one wrong. P to Q, these are correct. Now let us find the magnitude. So this one also 45 degrees. So if the current goes like this, we get definitely the BIL force towards right, like this, towards right side. So get the component this way, turn it like this. So the force is this way, you have to turn it like this towards the angle. When you turn it towards the angle, we get cos. So this way we get cos BIL cos theta, cos 45, theta is 45. And then there are two forces. One is BIL cos 45, that came from the magnetic force, the component from the magnetic force. The other force downwards along the plane is mg sin 45. That came from what? From the gravitational force, this one mg. The component of this one, like this, we turn along the plane, towards along the plane downwards. So then sin 45, because this normal is like this, the normal is like this, then the angle, this one is 45, therefore away from 45 we turn this mg away from 45. This one is 45, away from 45, then sin. If we turn the force away from a certain angle, we have to take sin. So therefore sin 45. So the total force now we can use in F equals ma equation. So BIL cos 45 means 1 over root 2 plus mg sin 45 is again 1 over root 2 equals m. A equals to g. In the question they say like that. Acceleration should be equal to g downwards. So now it is downwards actually, because these forces are directing to downwards. So then no problem, we can multiply by root 2, then cancel these people, then we get BIL alone here plus mg alone here equals root 2 times mg. Then BIL equals, we take this mg towards right, then root 2 mg minus because here it is plus mg, then we take mg out of the brackets because that is common, then root 2 minus 1 divided by BL, that is equal to I. So let us check what happened. Let's check with the answers. Which one? You have to select only from this blue correct marks, with the answers having blue correct marks, because that is the direction. This one has wrong direction. Root 2 minus 1 is this one, the fourth one. This one plus, this one 2 times root 2, and this one plus again. It's wrong. So the answer is obviously this one, fourth one, root 2 minus 1 divided by BL. So children, I think you must be able to understand what happened to your answer. Correct or wrong? Correct. Then you are genius, you can do this. What happened to your answer? Wrong. Don't worry. When you do these exercises again and again, you will be okay. You have to find out where you made the mistake. So definitely somewhere here, when you simplify, you must have made a mistake. If you couldn't find the direction of current properly using this left hand, try again and again using your hand, rotating so that it matches with this left hand rule. And first of all, you have to direct your index finger towards B. It is given in the question. So that way you have to first direct. So without changing it, you have to rotate your hand so that the thumb is directed to the direction to which we need the force. First of all, we have to decide this one, to which direction we need the force. We need here the force towards right side, because we need the motion to downwards. If we need the motion to downwards, we need the force towards right side. If we need the motion towards upwards, then we need the force towards left side. Then that is how. So that you have to decide by using your head, not by this left hand. That is your brain, that is your knowledge, that is your skill, because the force should be to the direction to which direction we need to get the motion. So if the force is opposite, we can't get the motion towards where we need. However, both are good, because you tried. If you don't try this, you are bad. That is what I have to say. I don't look at the answer, corrected or not wrong, correct or wrong. It doesn't matter your answer is wrong, but if you tried, one day you will fly. You have heard that, don't you? Try and try, one day you will fly. That is the slogan. So children, here is our target question number 4. As previously, try to do it, read the question properly, and get that into your head, and on your own, without watching my video, try to solve the problem. Pause the video. So now I am going to solve. As usual, let us draw the sketch, side view. The angle is given 30 degrees here. Then the wire. What they want us to do, a wire at g acceleration downwards, has to be accelerated by g downwards. So that means this way. A equals g downwards, g downwards. A means acceleration, you know that. So already we have a force downwards. What is that? mg sin theta, sin 30 in this case, and we need another force towards, we want to move downwards, therefore to this direction we need the BIL force. We don't want it to this way, because if we get it to this way, the resultant will be upwards. That is not we want. We want to move downwards. So to move downwards, we need a force that is helping downwards. If the force is towards this one, it will help definitely towards downwards like this. So to get the force to this way, F equals BIL, the current should be to which direction? So let us first use this way, your left hand rotated. If you have rotated your left hand like this, then let us try, because B is like this upwards. We need this one and this one. Therefore, let us place our left hand like this. B is okay, but the force is given by this, the direction of thumb, so it is to left side. It is to left side, so that won't work. That won't work. Therefore, let us rotate our hand like this. Still left hand. Still left hand. Let us rotate our hand so that the center finger is directed into the paper like this. Still the index finger is upwards, because B is given upwards like that. So we want the force towards right side. Therefore, let us rotate our hand so that the center finger is directed into the paper. Then you will find the thumb is directed to the direction which we need, that is right side. So like this. So this will work. This will work. So therefore, now look at the center finger. The current, that is the current, center finger is indicating the direction of the current. So it is into the paper. It is into the paper now. So now we know the direction of the current into the paper. Therefore, let us draw a cross here, and also the letter P. So into P, the current is going into P. Then furthermore P to Q. P to Q. P to Q is correct. P to Q is correct. This one wrong. P to Q is correct. P to Q is correct. The first step is done. Now the magnitude. So now if the current is going P to Q like this, and if there is a cross like this, the force is definitely to this right side according to the left hand rule. So the force is this way. Now we have to get the component towards this way. So we have to turn it by 30 degrees, because this angle also 30 degrees now. So towards 30 degrees, towards the angle, then cos theta. If we turn it towards the angle, cos theta. So this way we get BIL cos 30. Already there is this one, mg sin 30. So F equals MA So we have two forces downwards, BIL cos 30 means root 3 divided by root 3 over 2 cos 30. So this one mg sin 30, that also plus mg sin 30. Sin 30 means half, sin 30 means half, equals m, acceleration we need is a, equals g, a equals g, therefore only g here. Then let us simplify, multiply by 2 because the denominator is 2, then 2 times, then these people cancel, then remaining BIL root 3 plus only mg here plus 2 times mg, then 2 times mg minus this man here minus mg, then root 3 BIL. So 2 times mg minus mg is only 1 mg, divide by root 3 BL is equal to I. So these people we took, not I, these people we took to the down of the line, denominator to the denominator. So now this is the final answer. Did I make any mistake? No. Root 3 BIL 2 mg minus mg is 1 mg, right, I think correct. So let us check the answer. Mg divided by root 3, second one, this one, isn't it? Mg divided by root 3 BL. So we have the blue correct mark also, the direction is correct also. So the second one is the answer here, second one is the answer, second one, this one is the answer for this question. So if you are successfully done, that means if you also have chosen the second one as the answer, you are genius. If you are wrong, you are also good because you tried this without watching. If you honestly did, then only if you watched my solution, if you watch the video, the second half of the video, then you are not good. You have to try on your own. So let us go to question number 5 now. So children, here is our next target question, number 5. Try this on your own, honestly, without watching my video. Pause the video. A straight conducting wire PQ of length L and mass m has to be accelerated by g downwards on a friction, accelerated by g downwards on frictionless insulating inclined plane, which makes an angle 60 degrees to the horizontal. A uniform magnetic field of flux density B acts vertically upwards as shown in the figure. The magnitude and the direction of the current I that should pass through the wire in order to keep the wire at a g acceleration downwards is given by. So I think you have finished. So the angle is 60 degrees, 60. The wire is like this. So already we have downwards mg sin theta sin 60 then what they want us to do, acceleration equal to g downwards, so A equals g downwards like this. So to move downwards we need another force, because this mg sin theta is not enough. Mg sin theta is not enough to move with an acceleration g along the surface. It can move only downwards with an acceleration equals to g, directly, vertically downwards. If it is moving along this inclined plane, the acceleration is always less than g. Therefore this force is not enough, so we need another force towards this way, because if only the force is directed towards this way, then only it is helping to move downwards. If it is towards this way, it is opposed the motion downwards. So that is what we don't, that thing we don't want. So the angle is 60, so therefore BIL force must be towards this direction. So let us use our hand now. If you place the hand like this, if you turned your hand like this and placed here towards B is still upwards, so we don't have to mark it. We remember that the index finger, we have to first of all, the index finger we have to direct towards the direction of B, so like this. If the current is coming out from the paper like this, mid finger, center finger is showing, so then we get the force towards left side. So that we don't want. We don't want any force to left side. So therefore we have to turn the direction of the current opposite. That means towards the page. Towards the page. Center finger is directed towards the page. Now the current is going inside into the page, into the wire like this. So B is still upward. So now the thumb is directed to right side, so the force is coming towards right side. So that is what we need. So then now we know the current must be towards into the paper like this, into the paper. So therefore we have to mark a cross here into the paper. So point P is here, so into P the current is going into P, and furthermore from P to Q, P to Q is correct, this one wrong, P to Q is correct. Now already mg sin 60 is there, then plus we have to get the component of this one, BIL cos 60 is equal to F equals MA. So M times A is G. They have given it. Then mg sin 60 is root 3 divided by 2. BIL cos 60 is half equals mg. Then we multiply all the terms by 2, here also 2. If you forgot to place 2 here, then you will get another wrong answer. Then cancel mg root 3 alone here plus BIL alone here equals 2 times mg. Then BIL equals 2 times mg minus root 3 times mg. Then mg out of the brackets, 2 minus root 3 divided by BL is I. So this should be the answer. So let us check it. Second one. The answer is first one, isn't it? 2 minus root 3 divided by BL. First one. This one is the answer. So if you are successfully done, you are genius. If you are wrong, then you have to do again and again. You have to start from the first one. Here the target question 1 I taught you. So start again from here and follow it one by one on your own without watching the video. Then one day you will be able to get the correct answer. This is the path. So now let us go to another question, target question number 6. Children, here is our next target question number 6. As previously, try to do this on your own without watching my video. Pause the video, honestly do it. So now I am going to try this. Angle is 60. The wire is like this. Already we have the force downwards along the line plane mg sin theta, sin 60. So what they want us to do, g acceleration downwards. They should move g acceleration downwards. So we need the force towards right. Towards right. Then only it will help to move downwards. Now let us use our left hand to find the direction of the current. So let us first place left hand turned like this. B is here downwards. So we have to turn our hand. Let us keep this. Here B is downwards, like this. Then what shall we do? Let us turn our index finger downwards, like this. It will do, because the B is given downwards. So our index finger should be directed to downwards, like this. Then the current should come out of the paper. The thumb is directed to the right, to right side. So that is what we want. The force should be directed to right side because it should move downwards, therefore. So B is downwards, so our index finger is to downwards. So the center finger shows the direction of current, so it should be out. It should be out of the paper. So this finger is directed towards us, that means out of the paper. So here is a point of the arrow. So point P. So from P the current should flow out like this. Furthermore, Q to P is correct. Q to P is correct. Q to P is correct. P to Q is wrong. Q to P is correct. So let us find the magnitude. So mg sine 60 root 3 divided by 2 plus the component of this one, this say BIL, this one also 60 cos 60, because we are turning towards the angle, towards the angle. So this say we need, so therefore cos 60 equals mg, A is g. So mg root 3 divided by 2 plus BIL cos 60 is half. Those things you should have in your head, the value of cos 60, cos 30, cos 45. So we multiply by not root 2, just 2, just 2. So here also 2. Then these people cancel. Then alone root 3 mg plus BIL alone, 2 cancel, 2 times mg. Then 2 times mg minus this one, root 3 mg, here BIL alone. Then mg out, in brackets 2 minus root 3 divided by BL equals I. So now we have to select 2 minus root 3, first one, 2 minus root 3 first one, this one. This is it, first one. This one is the answer. So children, now let us go into wind up. We have done enough. We have done 6 target questions and also the original MCQ question, altogether 7. So children, now we are going to wind up. Today we did 6 questions. This one original MCQ problem, the number 44, and this one target question 1, this one target question 2, target question 3, target question 4, target question 5, this one target question 6. So I think you are very happy. If you couldn't get the answers correctly, again you have to follow from this 1, 2, 3, 4, 5 and 6. Then do several times. It will take times, but doesn't matter. One day you will be able to understand this left hand rule and this lesson, magnetic fields. So children, if you are happy, please make me happy also by subscribing my channel. If you haven't subscribed yet, then don't subscribe twice. If you subscribe twice, it will be cancelled. Then what else you can do? Share my link among your friends and also press the bell icon so that you get the message as soon as I uploaded the video, and also press the thumb up button so that I will be happy. Then children, Thanks very much for watching my videos, and for those who subscribe my channel, thank you very much. See you tomorrow at 6 o'clock in the evening. Goodbye.